What's up guys, Sir Gian here, and for this particular video session, we're going to discuss some problems involving generators and motors. Okay, so we have here two sample problems. Okay, so for this particular sample problem, so let's start. Okay, so determine the length of the wire if it cuts an average speed of 3 Weber of flux in 1.5 seconds. If the wire moving at a speed of 20 meters per second passes through a magnetic field whose magnetic flux density is 1.5 Tesla. So how do we do that? Okay, the first thing that we're going to do is to find the electromotive force E average. So how do we find E average? Remember that E average is simply equal to the flux P over the T, okay, or the time. Okay. So with this formula, we can now find E first. So we know that the flux is equal to how many? So that's equal to 3 Weber. And time is equal to 0.5 seconds. So dividing these two, 3 divided by 0.5, so that will lead to 6 volts. Okay, so that is our first step. So that leads to 6 volts. Now we've already found the average. We also have this equation that we know that the electromotive force E is also equal to the magnetic field density P, the velocity of turning or the velocity of the change where the wire goes off and out, okay, yung paglabas-pasok niya, at saka yung length. So E equals to BVL. So pwede natin gamitin itong equation na ito. So we know that E is equals to 6 volts. So we can manipulate this equation so that this can be turned to E average is equal to PVL. Ayan. So pwede natin siya i-isulat ng ganito. So after writing it like this, we plug in all the values. Okay. So I forgot this is the solution. So that 6 volts is equal to P. So do we have P here? So P is 1.5 Tesla. So velocity is meters per second, so we have here 20. And L, so that is the missing parameter, so the length. So that's how we solve the missing parameter. So that by manipulating everything, we can have L equal to 6 divided by 1.5 times 20. So 6, okay, so this will be divided by 1.5 over 20. So that the length required would be equal to 6 over 1.5 times 20. So we have here 6 over, so 0, then 3. So we have here how many? So 6 volts or 1.5. So that is 0, then 0, then 0, and then we have there 3. So 6 divided by 13, okay, so that is 0.2 rather, meter. Or, that can also be written as 20 centimeter. And that is our answer for part 1. So L is equal to 20 centimeter, and that's the answer. So do you have any problems or questions regards to this part? Okay, so if none, let's now go to the next part, or the next sample problem. Okay, so for this sample problem, again involving generators and motors. So we're asked what is the average voltage generated in a single conductor of a 4-pole DC generator if the effective flux per pole is 3 microweber and the speed of the armature is 1,500 revolutions per minute. Okay, so let's identify all of the given. Okay, or let's first identify what is the equation that we're going to use. Okay, so for this one, we're going to use the formula. E of G is equal to P N of Z. So I have discussed this in our concept video. It's up to you to observe this. Over 60A. So what is P? So P is the flux in microweber, so it's here. So what is P? So that's the number of poles. So how many poles? So we have here 4 poles. So what is N? So that is the revolutions per minute. So that is 1,500 revolutions per minute. And Z is equal to 1. So 60 times armature poles. So we have have also there 1. Okay. So how we'll now solve this? So let's plug in all of the values to solve for the unknown. So for EG, that is simply equal to EG equals to, so 3 microweber times 4 poles times the number of revolutions per minute times 1 over 60 times 1 again. Okay, since that is a single conductor and armature of 1. Okay, so single conductor, so that is equal to 1, as you can see here. Okay. So, by plugging everything and solving in the calculator, so we have your EG, so I have pre-calculated everything, and that's equal to 0.3 volts. Plug in everything in your calculator, divided by 60. Okay. Everything plug in the calculator, so we'll arrive with the answer EG equals to 0.8 volts. And that is the answer for our EG. And that's the average voltage generated in a single conductor of a 4-pole DC generator. So do you have any clarifications or questions with regards to these sample problems? So, if you have one, don't hesitate to send your private message. And if you have none, proceed to the next module. So good luck in your learnings. Hope you're enjoying all of the lectures.